is for compute. What you see on screen is a document which I've shared this morning with you folks when we were talking about the architecture center. This flowchart must be helping you to begin your conversations with your customers. So this flowchart should be a front runner. Sure, I understand that. Okay, we will be here till 5 minutes in the program. So this flowchart will be your starting point in order to choose the right solution for your customer. So the question is, what is the right solution, right? So the simplest answer would be, it depends. For example, if a customer says, hey, I need an environment where I can run my application, but I need the full control. So if control is something which is looking for, then infrastructure is the service. Infrastructure as a service is the service that you should go with. However, at the same time, if he is looking for greater flexibility, less management overhead, then that's where the platform as a service offering comes into picture, which is where we can also think about something called your Azure App Service. So less management overhead. Excuse me. So this one is a platform as a service offering. So the question is, should I go with infrastructure as a service or should I go with platform as a service? Depends on the customer, depends on the workload type, depends on the type of control they want on that particular resource. So the primary option to choose which compute service should I go with completely depends on the type of workload. For example, if they're talking about cloud native applications with scalability, they can think of all three different types of solutions. Infrastructure as a service, platform as a service within Azure App Service. You can rely either a VM-based solution or a container-based solution. If they're looking for a solution just to respond automatically for the events that have been generated. Okay, so what are the controls we are referring to? So the first control is the question, the control. When I say control here, the operating system level control, hey, I should be the one who can control the operating system as well as the runtime environment as well as the application itself, which if I'm talking about infrastructure as a service. Does this make sense? You have the control to configure your network and storage as well, rather than selecting the options which are offered to you. If somebody wants to mimic on-prem environment, the closest option for on-prem is your virtual machines. Give me a thumbs up if you're following me, Vijay, if that answers your query. Thanks, Roshan. So now let's get going. How many of you have never created a virtual machine? Just raise your hand. You can use the raise button on the top right corner. If you have never created a virtual machine in Azure, just raise your hand. Okay, we have 2. That's all right. Like I said earlier, unfortunately, this training program doesn't give you the option to perform any hands-on lab. We don't have any Azure passes. We don't have anything associated with the implementation. Because in design concepts, it's more of the discussions that you're going to do with your customer rather than implementing stuff for the customer. Okay? Not on Azure, but on AWS and GCPS. Okay, no problem. So what we'll do is, I'll just first quickly show you how IT has been transformed. Then we will talk about how quickly can we create a virtual machine, just an interface to understand what is that you should consider when you're designing a virtual machine. Because without knowing how to create a VM, you can't understand how to design it, right? So if you look at this diagram, what we have here is the different stages IT has transformed. If you remember from my experience, I told you that I started working for HP. So this was back in 2006, right? 2006 to 2009. Then I moved to Dell, 2010 to services, which was primarily dealing with enterprise customers and with servers and their MSA boxes. While I was supporting the Proline series of servers, I was also dealing with C7000 chassis, which was again a plain server configurable option available for large enterprise customers. So in olden days, back in 2006, HP was still a big thing. Dell was still a big thing. When I say big thing, your infrastructure required for you to run your on-premise data center was still offered by these big companies, right? So back in the day, if a customer wants to offer its services for an application, a customer would buy a server, example BL380, install the OS, install the application. This is what you do. This is the same thing which you do with your laptops as well. When you want to run an application for your productivity, you need a laptop. The laptop basically consists of CPU, memory, network, and storage, which is your base layer. On top of it, you're running your operating system, example Windows, and on top of it, you're running your applications, productivity applications like Excel, PowerPoint, Word, or other documents, right? So this is what people used to do in an enterprise. This was not efficient. Why? Because when you buy a server with few thousands of dollars, the utilization of that server was only 15% on an average. This is as per Gartner's report. So how do I increase that utilization? Because for thousands of dollars that I'm investing on a server, 15% return ROI is very, very less. So how do I achieve more? This is where people came up with something called virtualization. So whenever people talk about virtualization, I want you to remember these four terms: abstract, pool, share, consolidate. What are these four terms? Step one doesn't change. If you see here, you still have to buy the server because that's your base layer, which offers CPU, memory, network, and storage. Step two, rather than installing operating system, you will install something called hypervisor. This is the step which we are changing. So your hypervisor is the guy who brings that abstraction layer. That's why I've written abstract at the hypervisor. The basic job of hypervisor is to create and manage virtual machines, which is where we are talking about the software computers. Because it's a software computer, you can install operating system and you can install application. So if you see here, the basic difference between picture number 1 and picture number 2 is earlier on the left hand side in picture number 1, you were running only one application. But now on the right hand side, on the same physical server, you're running multiple applications. This is where the term consolidate also comes into picture. So as per Gartner's report, the consolidation ratio is 1:10, which means on a single physical server, you can run as many as 10 virtual machines. This is minimum I'm talking about, okay? Which means 10 different applications on a single box with isolation, with security, and with all the other advanced configurable options available to you. So abstract is the hypervisor. Pool, the job of hypervisor is to pool the resources. Share the resources with the virtual machine. Consolidate, which means you're running more than one workload. So the basic definition of virtualization is running multiple workloads on a single box. How? By sharing and pooling the resources. So that's exactly what we have. Just give me a thumbs up if you're following me. Difference between physical versus virtual. The four terms that I want you to remember is abstract, pool, share, consolidate. These are the four terms which I want you to remember. Now what are we doing in stage 3? Stage 3 is easy. Hey, whether it was stage 1 or stage 2, who's buying the server? You. Who's buying the operating system? You. Who was racking them, stacking them, configuring network, configuring storage, setting up everything? You. Which means more time. So this is where cloud comes handy. The first easy definition for cloud is cloud hides complexities. How is it doing that? Hey, if I were to run an application in the cloud, all I need to do is first create my own isolated network. Why? Because cloud is shared by multiple customers. I don't want other customers to view what I'm doing, to get access to my resources. So how am I going to stop that? By creating an isolated network. So that's what we have. Now that isolated network is segmented. How am I segmenting it? That's where subnets come into picture. What am I doing after that? I'm just creating my virtual machine. So 3 steps. Create a network, create a subnet, deploy your virtual machine. So if you see here, cloud has always been a remote data center, which means when you create a virtual machine in the cloud, what is actually happening? Somewhere in the remote data center on a physical server where your host is, which means where your hypervisor is, you're just running your virtual machine. So why am I going with cloud? ILO is what HP calls it, and then DRAC is what Dell calls it. The terms were different, but the functionality, the hardware, everything was same. Even when you open the box, both boxes have the hardware which were made in Taiwan, right? So this is where I want to pause for a quick 5 seconds and ask the same question. Any questions so far? From physical to virtual, from virtual to cloud. Now keep in mind, cloud is built on virtualization, which means without virtualization behind the screen, cloud doesn't make sense. Because virtualization is the one which allows you to consolidate your workloads, which allows you to make your environment more efficient. That's why if you are a private cloud administrator, you would know things like, if I'm talking about VMware's environment, you would use ESXi, which would be your VMware's hypervisor, and then vCenter server, which will be the hypervisor manager. Then you can bring in vRealize stack, which gives you that portal access from where you can demand for resources when you require that. That's what they call it as vRealize automation. And then you can automate the deployments through something called vRealize orchestrator. So all this, if you have worked on your environments in a private environment before. All good so far? Just give me a thumbs up, people, if you're following me. Thank you. Let me quickly show you. Because like I said, in order to design a solution, you must deploy it at least once. That's my way of learning stuff, right? So if you go back to the cloud, okay, this was with the logs here, trying to move. Let's see what happens, okay? Now, meanwhile, I'm going back to the virtual machines. I'm going to create a new virtual machine. I'm going to call this as VM01. I'm going to call it as VM01, right? Which region? East region. I'm not going to explain you all the options, but if you look at the questions, first question is subscription, second question is resource group, which means even before creating the virtual machine, you must have your organization structure in place. How are we mimicking the organization structure? Remember, we've already talked about managing your subscriptions through the concept of management groups. So have your management groups in place, have your subscriptions in place. And then resource group, you can create your new resource group or use an existing one depending upon your use case. Virtual machine name, region, availability options, which basically talks about how you're going to make this resource highly available. So I'm just going to go with the default, no infrastructure redundancy required. Security type, if you want to go with virtual PPM integration, or if you want to make it more confidential virtual machine, you can select the option. I'm just going to go with standard here. Image, what you want to install? I want to install Windows Server 2019 x64 architecture, 64-bit. Then it is asking me which size. See here, there are different sizes. Each size, the price vary. I'm just going to go with the DS2, the default version. It's asking me username, admin root, password. Just define a password here. And then do you want to open the port 3389 so that you can connect to this virtual machine remotely over the internet? I'm saying yes to that, which will configure your NSG, Network Security Group, automatically. What is NSG? Why does it important? All that we will discuss it on day 4. Licensing, if you want to use your on-premise Windows license in the cloud, you can do that. Hybrid licensing is what we call it, hybrid benefits. So would you like to use an existing Windows Server license? If you have one, you can check this box. I'm not doing that. Next step is storage. I'm just going to say here I need standard SSD. How do you want to encrypt the standard SSD disk? I'm going to use platform managed keys. With keys, we encrypt the disk so that any data at rest is encrypted. So I'm going to go with platform managed keys. Then under networking, it is asking me, so which network do you want this virtual machine to be part of? I already have an existing network called VNet01. From the drop-down, you can see other networks 0204, right? It also depends on the region. If I have not selected the right region, these would not be available. For example, if I go back to basics, and if I select West US, I'm just gonna say West US. Okay. Now, if I don't have any networks in West US, that won't show up. See here? It says new. Why? Because I don't have any networks, virtual networks in West US region. Earlier, you could see VNet 01, VNet 02, VNet 04 because these networks exist within that region. But the moment I change the region, I don't see that. So, whenever you're designing your virtual machines, point number one, most important point is decide the location where you want to run your virtual machine. Then determine the size, because size affects the pricing, which I've shown you. See here, if I click on see all sizes, where is it? See here, we have B series, D series, E series, N series, so different series. Within D series, we select DS2, right? But if you go with other option, version 4 versus version 2, this is $73 per month. The other one is like $356 per month. So the moment the size changes, or let's say I want to go with T series, which is high memory needs because I want to install some database on this. Check this out, pricing differs automatically. So what I'm trying to highlight here is, after you decide the location, the second important thing that you need to understand is decide the size of the virtual machine while designing your solution. Then we are talking about network. So if I were you, I will put network at the beginning, start with the network, decide the location, determine the size. Then we are talking about image, which is where we have talked about operating system. And then what else? Storage options, which is where we have talked about standard SSD, and then I'm going to use platform managed keys to encrypt the data. So these are the main important questions. So if you see here, after you configure your username and passwords, after you configure your disk, after you configure your networks, under management, things are basic. Things are like, hey, how do you want to authenticate to this particular virtual machine? Do you want to integrate Azure Active Directory accounts? Do you want to auto shut down the virtual machine? Do you want to enable backup of this virtual machine? Do you want to configure site recovery, which is to replicate this virtual machine to a different region, right? How do you want to manage guest operating system updates? All these things we discuss much more in detail and we do practically in AZ-104 class. How do you want to enable monitoring, alerts and diagnostics information? How do you want to collect it? If you are collecting it, where do you want to dump it? Do you want to dump it in a storage account automatically created by the platform? Or do you want to create a separate storage account for this? All this kind of things. Advanced is like post virtual machine configuration. Once the VM is created, do you want me to configure something on the VM? Maybe to install a backup software, maybe to install a monitoring software, or an agent for your firewall. So it could be anything. So any post deployment virtual machine configuration, we do it through extensions. That's exactly what we're showing you here. Tags, review, and create. So the reason why we are going to get the validation error is because of the Azure policy that we created. We said everything must be in East US, and then here we're missing something, which is valid password. Okay, so now let's go back to review and create. If everything is good, if the policy is not causing a conflict, you should be safe. It still says policy failed, it's because of the policy. The reason why, because under basics, we selected West US rather than East US. Just give me a thumbs up. This is how we create a virtual machine. The moment you fix this and then say create, a virtual machine will be created. Give me a thumbs up if you're understanding how to create a VM. Again, all this is what we cover in an AZ-104 class. So here, these are the different sizes of virtual machines which I've just shown you. D series, B series, F series, E series. So depending upon your use case, for example, if you're creating a database virtual machine, then it makes more sense to go with E series because database requires more memory to be faster. E series virtual machine gives you high memory to CPU ratio. What if I'm running a gaming application? Go with N series because N series gives you more graphics. What if I'm going to run big databases like SAP HANA? Go with H series, high performance compute. General purpose web application service, go with B series or DT series. So depending upon your requirement, you will choose. So if you remember, the questions that we have discussed was start with the network, decide the location, determine the size, image, operating system. All these are the questions which one should ask when designing a solution. So that's what we have written here. And then, if you're not sure which virtual machine to choose, don't worry, we have a tool. We have a tool called VM Selector. So basically, it's going to ask you some basic questions. Once you have answered these questions, it will recommend which size virtual machine works best for you. For example, let's say I want to go by an operating system. I want to run Windows Server. Memory sorry, I'll just select all. I'm going to go with the defaults here. I'm going to go with premium SSD. Location, I'm going to go with the default United States. So here, it clearly says here, if you're going with A-series virtual machine version 5, with 2 virtual CPU, 16 GB RAM, storage, you have not defined the size, which means I'm not going with any temporary storage. Pay-as-you-go model, you will be ending up paying $82.49 per month. When you click on view details, it will clearly tell you for 1 year, this is the price. If you reserve upfront, 3 years, this is the price. Spot instance means if you're okay for the virtual machine to be deleted by Microsoft when there are resources in crunch. That's where the spot instance comes into play. Which means if it's a testing environment, go with spots because it gives you 90% savings. So you can clearly see how pay-as-you-go model is the expensive offering in Azure. EA, Enterprise Agreement, which is reserving the resources upfront through a monetary commitment like 1 year or 3 years, it's going to definitely give you better savings. Give me a thumbs up if you're following me, people. From 68, it came down to 31. So this is a tool, which is like known as virtual machine selector tool. Depending upon the options that you have selected, it will work. For example, here we select premium SSD. Then here, we're saying add disk with size 4 GB, I'll say 32 GB, add disk. Default region, now check out the price. This is only for the disk. $5.28 per month. This is where we'll pause. We'll bring up the same question if you guys have any questions. So what we have discussed so far is when you are about to choose the right compute solution, the first solution which comes into play is virtual machines. 5 points on virtual machines. Number 1, it's an infrastructure as a service, which means it gives you more control than the platform as a service offering. Number 2, choose the right size, choose the right location, choose the right network. So which means you have to configure all of this even before you come to the page when you want to create the virtual machine. That's point number 2. Point number 3, virtual machines are of different sizes, right? So this is where we said go with E series if you're running on database, go with N series if you're running any high performance compute workload. And point number 4, use virtual machine selector tool, which allows you to choose the right virtual machine depending upon your requirements. Point number 5, virtual machines can be moved from one place to another place, which means from one subscription to another subscription, from one resource group to another resource group. That can be done. Everybody good so far? Any questions? Pricing is one of the major factors, at least here in Southeast Asia, for you to choose. How do we monitor the health of the virtual machine? This is where Azure Monitor comes into play. For example, you can go back here, the portal, home, Azure Monitor, Azure Monitor, alerts. So you can monitor metrics, logs, activities, and then if you want to get more insights into the virtual machines, this is what allows you to see here. complete monitoring of your Azure and hybrid virtual machine environment. So the simplest answer is Azure Monitor. Give me a thumbs up, Manoj, if that answers your query. Thank you. So let's get going. One of the other solutions which come into play whenever we talk about compute is Azure Batch. Now the first question that comes into play is, what is Azure Batch? Point number one, it's a platform as a service offering. Point number two, it helps you run large scale applications efficiently in cloud. So what does it do? It helps you schedule compute intensive tasks and then allows you to dynamically adjust the resources when required. So is this kind of creating a pool of compute nodes and then running an application on these compute nodes? Exactly, yes. So what kind of workloads can I use Azure Batch for? All these are few examples. For example, you can run engineering simulations. So you can run simulations in parallel. So here we're talking about image processing and rendering as a simple example. Converting a normal movie into a 3D movie. That's a lot of work, right? You have to do a lot of image processing and rendering. That can be offloaded to workloads like Azure Batch. ETL, extract, transform, load, where you allow you to run your transformation task in parallel, Azure Batch. Monte Carlo simulations. So all these are deep learning models. All this can be done through Azure Batch. Can you use Batch to schedule API calls? Yep, definitely yes, you can do that. So whenever you're dealing with Azure Batch, you will hear a few terms like, what is a job? What is a task, right? A job is a collection of tasks, in simple terms, which will be executed in parallel. Example of job can be, hey, run 10 different simulations of this model, run 1000 iterations of this transformation script. So when you go with such examples, it clearly says, hey, in this particular job, I have to do 10 different tasks. That's why we say job is a collection of tasks. What is a task? It's an individual run of the job. For example, when we say run 10 different simulations, we are talking about one run is equal to one task. 10 different runs is equal to 10 tasks. Downloading input files from Azure storage, or running a particular script, or uploading a result back to Azure storage. All these can be a task. So how do I get started? So this diagram here I've taken from this KP article which I've highlighted, which talks about how Azure Batch really works. So it all begins with uploading the files to the cloud, which is what step number one is, uploading the input files and the applications to process those files in the cloud. Second step is to create a batch pool of compute nodes. Third step is to download these input files and then the applications to batch. Fourth step is to monitor task execution. Fifth step is to upload the task output. Sixth step is to download the output files. So these are the 6 steps which you will generally see whenever we are talking about Azure Batch. Now, best practices and useful tips for Azure Batch service is consider the size of your pools accordingly. Make sure when you are configuring your nodes, individual nodes are not guaranteed always to be available. And then when you're talking about jobs, uniquely name your jobs. Let's go back to the article which I've shared this morning. Is it equivalent to AWS function? Because we have Azure function, which is on-demand execution of a particular code when an event is generated. So I'm bringing back this article. I'm going to search for function. AWS Lambda is Azure function, but I don't see AWS function. Let's search with that keyword, AWS function equivalent. Is it called step function by any means? time-based function. Yes, this is what we saw. What do you mean by AWS function then? Because I don't see anything called AWS function in this article. But if you're talking about on-demand provisioning serverless technology, yeah, then it's Azure function, and it's called as Lambda in AWS. Wonderful. Okay, then we have a very good question from Vijay again. Does batch trigger tasks within the same account, or I can use this replacement to batch scheduler like controller? I mean, it depends. If you have an enterprise application which needs to execute a script and then get the files from the storage account and upload the results back to the storage, Azure batch can be of use. Okay, it's not necessarily a replacement to a batch scheduler, but in general, all your batches are automatically scheduled by Azure Batch itself. Not really. That's a different service altogether. I mean, we are just limiting it to compute, but when we are talking about your Azure Cycle Cloud for HPC, that's a different ballgame altogether, which is where I've heard terms like HPC with AI. So these are the steps that you will consider whenever we are talking about your Azure Batch service. So if you have worked on VMware's VRO, Visualize Orchestrator, so sorry, VRO, no, Visualize Orchestrator, I think this is somewhat closer solution for Azure Cycle Cloud. Because it allows you to rely on IAC, which is infrastructure as a code, and then allows you to go ahead and orchestrate and manage all those workloads in Azure. Yeah, welcome. So now let's get going. Then we also have another platform as a service offering called Azure App Service. Now, in a simple discussion, let's say you want to deploy a web application server for your customer. If I'm going to do this on Windows platform, step 1 is to create a virtual machine. Step 2 is to install a Windows operating system. Step 3, launch the Windows Server Manager. Step 4, go to add roles. And then step 5, add a role called IIS. Step 6, configure the IIS page. So these are the 6 pages that I'll do if I want to configure a web server. How do I trim it down to just 2 steps? This is where app service comes into play. What is an app service? App service allows developer to create and manage applications faster. Now that application can be a web application, that application can be a logic app, that application can be a mobile application or an API-based application, right? All this is to optimize your developers' work, which is where DevOps love Azure App Service. It supports containers as well, which means you have the option to choose whether you want to go with app service using virtual machines as your backbone or using containers as your backbone. One of the important reasons why developers love app services because it allows users to choose their own programming language, whether it is .NET, .NET Core, Java, Python, PHP, Ruby, all these languages are supported, right? Now, app service helps you concentrate on your code rather than the components which are involved to run that code smoothly, which means your platform, which is basically the operating system layer and the hardware layer, is taken care by Microsoft itself. So here, this is what we say. As a customer, you'll only worry about the code with which you run your web application component. Platform operating system is taken care by code side by side. For example, I have production environment, I can have a staging environment. Production environment, let's say it's running on version 1, staging can be 1.2. So I can route a percentage of traffic to the staging environment. And if everything works good in the production environment, then I can move the 100% traffic to staging. So this is what we are talking about. Then we also have something called ASC, application service environment, which are to run your application in your own network. Basically, in platform as a service offering, you don't have the control where your application is running, which network, because that's taken care by the provider. But if you want to take control in your hands, and if you want to drive the way for your networking, for your web application component, you can do that with ASC, App Service Environment. So all these are the terms which will generally come in. And this generally shows a typical web application diagram, how you would deploy it in Azure. Step 1, you would create your resource group. Step 2, within that resource group, you would configure your application service plans. Step 3, you would deploy your web application. Step 4, you configure your deployment slots, production, staging, or last on good configuration. And then you would integrate your application with databases, Azure Monitor, Azure Active Directory, and Azure DNS for it to run smoothly. I'm going to pause here for 30 seconds. Record the points on screen. What is Azure App Service? What is App Service Plan? What is Deployment Center? Deployment Center is just an option where you can go to manage all your deployment slots. Deployment slot is basically a configuration bundle which allows you to test your code. Multiple versions of the same code can run side by side. Any questions here, guys? Any questions? All good so far, people? Just give me a thumbs up.
I've got one question in the chat.
Is App Service code portable? One Azure, one AZ to other AZ account. One AZ to other AZ account. So keep this in mind. Your accounts come into play whenever we are talking about you setting up your enterprise departments. So it's called up, which we have discussed this morning when we were talking about subscriptions. Let me pause to the subscriptions here. Where here it should be. Yeah, see here? Your accounts are under the departments. So if you're asking me if the service app code, app service code portable, as long as you're talking about your code being available to you in public repositories. Primarily this comes handy when we are talking about container being your backend instances for your code to run, whether it is coming from ECR or Docker Hub, you can implement it. You can get that code between accounts. Is that what you're looking for, Vijay?
Yeah, that's right. Thanks.
Welcome. So that was our app services. Let's talk a little bit on containers first. Then we will talk about AKS. Then finally we'll talk about Logic Apps and things. I'll just cover containers, then we will take a small 10 minutes break, come back, talk about Azure Functions and Azure Logic Apps through the deck. Then we will get started by 2:30. We will get started with our case studies. We have 2 case studies for today. So what you see on this whiteboard right now is a quick differences between a virtual machine and a container. Now, if you see, there's not a lot of difference between them. How, you might ask? If you remember, I asked you to remember 4 terms. Consolidate, share, abstract, pool. Consolidate, share, abstract, pool, right? No problem with that, go for it. Now, when we say consolidate, running multiple virtual machines on a single server. Pool, hypervisor pools all your resources. Share those resources with the virtual machines. And then abstract, the hypervisor itself. The basic difference between virtual machines and containers is hypervisor came into play. But the moment hypervisor came into play, direct access to your hardware resource is never allowed. It says stop. Anything that you want, you contact my hypervisor, the hypervisor will give you the resources. This is what abstraction means. So where are we applying abstraction here at containers? We apply it at the OS level because they've always considered OS to be the monster. Think about your laptop. Without you running any application, how much resources is your laptop eating up? CPU, memory, network, and storage. Approximately 25 to 30% of your resources, right? So how do I make it more efficient is where they thought of bringing the abstraction layer at the OS level, and that's what exactly CRE does. CRE stands for Container Runtime Engine. The job of Container Runtime Engine is to abstract your operating system so that you can run your application and binary code as a package, and that package is what we call it as a container. So in simple terms, a container is an application code plus the binary is required for me to run that application code successfully. No operating system. So that's exactly what I've written. So the abstraction happens at the OS level. OS is the one who's going to pool your resources and share the resources with containers. Containers are consolidated, which means you're running multiple applications on a single operating system. So how do I implement it? You can implement containers in two ways. Number one, you can make your virtual machine a container host, or number two, you can make your physical server a container host. Why should I go with containers? For me, the most important point is lightweight. Containers are small in size. Powering on, powering off, moving them, managing them becomes really easy. Ultra portable is the second reason, which means I can create a container on my laptop, I can test it on a physical server, I can host it on a cloud without making any changes to the image. Image is nothing but a stock container, which can be considered as a template if I'm talking about virtual machine terminology. So what I'm trying to highlight here is containers are ultra portable. Whereas when I talk about moving a virtual machine from VMware's platform to AWS, or AWS to Azure, or Azure to GCP, I need some kind of converter tool. Without that converter tool, you can't move your VMs from one platform to another platform. Whereas in containers, that's the flexibility, right? You upload your container image to a secure repository like ACR, Azure Container Registry, or Harbor, which could be your own private container registry, or Docker Hub, which could be a public registry. And as long as you have access to these registries, you can download and then run containers anywhere. The only condition is the base should be same, which means the container host operating system must be same. If you created this image when the container operating system host was Linux, you still need Linux container host anywhere you go. So that's ultra portable. Containers are scalable. Containers offer isolation like your virtual machines. So all these are the reasons why we should go with containers. So what are the challenges of a container? Number one, how do I restart a failed container? Number two, how do I configure load balancing networking for thousands of containers if I have a large enterprise environment? Number three, how do I configure storage? Number four, how do I restart a failed container? All these are reasons to fix, and that's where they bring up something called COE, Container Orchestration Layer or Engine. COE. What does COE does? Babysits your container. What do you mean by babysit? Hey, this is the guy who will take care of your initial configuration like networking and security and storage, right? This is the guy who will restart the failed containers. This is the guy who will take care of your deployments to offer high availability. All that is taken care by your COE. So when you look into the market for COE, there are solutions like Kubernetes, Mesos, Swarm, right? Kubernetes becomes super hit. Why? Because of its plug and play architecture. So whenever people talk about Kubernetes, they talk about the architecture, master, worker. In master, you will have components called API server, controller, scheduler, etc. In worker, you will have kubelet, kubeproxy, Docker, pod. I took 3 months to study Kubernetes and take up the certification. I can't teach you Kubernetes in the 10 minutes quick run through, right? So this is just a high-level overview for you to understand that there are multiple different compute service offerings available to you. So coming back, what is an API server? There's like entry and exit point. If I'm a developer, I will use tools like kubectl, and I will talk to the API API server to understand what's really happening with the cluster that I've deployed. Controller is the guy who always monitors API server. Depending upon the instructions given by the developer, he is the one who offers different functions. For example, one of the functions he offers is resiliency, which means replication. So when you say your deployment should be highly available, this is the guy who's maintaining those number of replica copies for your deployment. The term deployment in Kubernetes refers to an application deployment. Scheduler, it basically balances your pods across multiple worker nodes, which means if a developer says, I need my worker, excuse me. If developer says, I need to deploy this container with 8 gig memory, 4 virtual CPUs, and then 20 GB SSD capacity of storage, and then a gigabit of network, it is a scheduler who will find the right working node that matches the requirement of the developer to run that container. So scheduler always balances your pods across worker nodes. HCD, basically a database, key value store, keeps all your current configuration status of your Kubernetes cluster here. So those are the components of master. Worker node, you have something called kubelet, which always listens to the API server, also known as the API agent, and then implements the instructions given by API server. Kubeproxy, the one who takes care of networking and load balancing for your worker node. Docker is basically a piece of software that runs your container, also known as the container runtime engine. Pod is the smallest execution unit for your container. Compare pod as a room where your container sits. A typical Kubernetes diagram looks something like this. The orange box is your master node. The green boxes are your worker nodes. What are we doing with AKS? We even make it more flexible for you. We'll remove the orange box management from your shoulder, which means orange box is maintained by Microsoft, and then the green boxes is what you would take care of. Just give me a thumbs up if you're following me so far, people. By default, most of the time in a single pod, you will run only a single container, but sometimes you will see a pod with multiple containers. We call them as primary container and a sidekick container. Sidekick container can be like a log forwarder to forward logs, can be a antivirus, can be a backup agent, it could be anything. Just remember that. So these 8 steps, which I'm going to copy and paste it in the chat box, are defining how the communication between these components really work. So if you see here step 1, you as a developer run an API to create a workload in Kubernetes. Your API server creates a pod, updates HCD, saying that a pod is created. Step number 2, scheduler who's continuously monitoring the API server understands, hey, that there is a new pod created and no node is assigned. In step number 3, scheduler selects the best server for this particular pod and talks to the kubelet of that particular, informs the information about that particular server to API. What will API do then? API then talk to the kubelet on the appropriate worker node. What will kubelet do? Kubelet will update the status to the API server saying that I'm going to work on it, creates a pod, deploys the workload, updates the HCD server. Step number 9, API server then updates the information in the HCD. Yes, that's a very good question. Vijay is asking, can I do Kubernetes updates without downtime? So in Kubernetes, there's a concept of rolling over updates. Yeah, this is the article. So when we say rolling updates, at any given point of time in your deployment, there will be at least one pod which is running. It won't take down the whole pod. Check out this diagram. So what is AKS? Like I said earlier, we remove the management overhead from your master nodes, and you will work with your worker nodes. You will decide who gets access. You will take care of the security for your worker nodes only. So this is where we will pause. It's 1:55 p.m. I'll give you a 10 minutes break. Just refresh yourself. Come back. We'll start with the deck. At the end, we will talk about Azure Functions versus your Azure Logic Apps. Then I'll give you the instructions for your case studies. Then we go off for the discussions. So take a small 10 minutes break. Let me bring up the timer. I'm going to start the break, scan the QR code, be back in 10, and we will continue forward. Thank you guys.